We just avoided the introduce the speaker. If you really want to know more about me, it's just go have a look at the summary of the talk that's on the website for PyCon AU. This talk is all about modules, what you need to know about modules to help you design good code. So we're going to cover a few things really briefly today, and please don't stress if you don't get all of this written down or anything like that. I'm going to make the slides available. And the slides are fairly word heavy because I've designed these to be sort of more takeaway notes that you can use as a future reference rather than just a few pithy sayings that I speak to over the next 20 minutes or so. But by the end of this, I hope you understand good practices with using modules and packages, how it helps your code, and I'm going to list a number of advanced topics that we're just not going to touch on today. This is a big area, but what I want to do is give you the seeds of information that you will need to know as you advance as Python programmers so that you know where to go next to look for more information. And for this conversation, I'm going to talk about building software. And we always talk about building software as if it's talking about real buildings. You know, we architect things, we construct, we make. We have software architects. We rip off design patterns from real architects. You know, Christopher Alexander was a real architect who developed design patterns for architecture. And we came along and went, geez, that's a great idea, and pinched it. We have frameworks, structures, foundations, all sorts of things like that. The key message I want to give you is, while it's a flawed metaphor, a lot of it does apply to software, that different buildings do require different skills and different approaches to planning and design. So if you're building a TP, and in software land that's, you know, a 2-line awk script or a little bit of quick Python to just do a one-off job, anyone with an ounce of intelligence can do that. That's really easy. And if it falls down later in the forest, does anyone hear it? Does anyone care? When you get to your cubby house, though, you've actually got to put in a bit of effort. You need a saw, you need a hammer, you need nails. You need to actually stop and think about whereabouts in the tree am I going to put this. And no one's going to come and talk about planning permits, at least not in my council for this. No one's going to live in this forever, but it still does require a bit of skill. This might be, you know, the script that a system administrator runs that checks some log files every night through a cron job. It's, you know, a 10-line Python script. It doesn't go into production anywhere, but it's still got, you know, a bit of structure to it. By the time we've got to houses, we are actually starting to talk about some serious skill. You've had an architect design this. There's planning, there's permits. You've got your plumber, your electrician, your painter, your carpenter, your tiler. They come together, and if you're actually going to build a house that's going to last a long period of time and get approval, and that you'll actually be able to put on the market, that people want to live in, that can be easily renovated or extended when more kids come along or something like that, you are starting to talk about some serious skill and experience. This is your jet fighter software, your cochlear implant firmware, your MyKey ticket system if you live in Melbourne. It's the stuff that requires a lot of expertise to make sure that A, you build it right, and B, it doesn't fall down around you, not only taking you out, but everyone else within a 10-block radius. This is the pinnacle of A, building, but also software engineering. And hopefully you can see the progression and the demands that you have in terms of architecture, structural engineering, planning approvals, the sheer size of the team and different skill sets required for a job like this versus your TP in the forest. So obviously getting the design right is critical, and the larger your software project, the more important it is. How easy can you get in there to fix bugs? How easy is it to test? Can you actually go back and read the code the next day? Put your hands up if you've ever programmed in Perl, and that's my one cheap shot for the week. Can you go back and understand it in 2 years? And I've certainly written code where I've gone back 2 years later and gone, who wrote this? This is shocking code. Picking up code that you've got to maintain that someone else has written. How do you wrap your head around it? If it's one file of 1,000 lines where people haven't used functions, they've just started at the top and just written it all the way to the bottom, how do you untangle that sort of mess versus something that's been really cleanly partitioned, well designed, small parts that you can easily wrap your head around. Frank Lloyd Wright, probably the 20th century's most famous American architect. This is the Waterfall House. It's just a stunning piece of architecture, inside and outside. It fits within its elements. It is one of these masterpieces of architecture. And while all of the software we write may not live on in perpetuity like this and grace the front covers of housing magazines and that, we would like people to think about our software as beautifully written, aesthetically pleasing, fits within its environment really well. This, on the other hand, as the customer, I can see you tried to do the right thing. Yes, you built me a house. I asked for a house, and yes, you built it, but I'm going to struggle to actually live in that house. And this, it may be a house, and I can see how it started, and I can see how you've bolted things on, and yes, maybe people could still live in it, but I wouldn't. I'm worried it's going to fall down around my ears any day. So how do we avoid those sorts of scenarios? There's a range of basic design principles that people who, particularly if you've come out of an object-oriented background or a functional programming background, will talk about. Things like separations of concerns. Don't lump everything in together. Understand responsibilities, interfaces, keep them separated, really well defined. Abstraction. Don't repeat yourself. Wherever you can, do not repeat yourself. So you just do not repeat yourself, okay? Composition, understand how to actually compose your components so that they work well together and that they're loosely coupled. You don't want components that are so tightly interweaved that you can't actually separate them, and they're really not components. They're just some sort of a blancmange of components that have all melded into each other. And out of functional programming, things like the concept that a function always returns the same value makes testing and proving your code so much easier. Minimizing or eliminating state, and we'll come back to how that gets you time and time again with Python modules in a minute. And the thing that we really want to avoid is people talking about our code as duct taped together, sprawling, sloppy, spaghetti code. And if you ever want to read a classic paper about how you end up with that sort of code, the Big Ball of Mud paper is a classic on that. And we've all written code like this. Well, I'm being presumptuous here. I have written code like this. The aim is to not be writing code like that. So you use modules and packages to give yourself smaller pieces that are logically grouped together, if necessary in hierarchies that are really easy to understand. They're designed for reuse, they're designed for testing, they have well-defined interfaces that allow you to use them, to deploy them, document them, test them really easily. And looking at something like that is just far more pleasing to the eye. You can pull out, even if you hate UML, you can pull out a diagram and actually wrap your head around how all of these files, or how functions and classes fit into files that are modules that fit into packages that have a certain responsibility. So what's a module? I'm going to start fairly basic here, given that I know there's quite a few beginners here. I'm just going to run quickly through the basics. At its simplest level, a module is a Python file that contains definitions for things like your functions and your classes. And when you import that module into your code, it's executed. It's executed once at import. It has its own namespace, which is essentially a symbol table where it has an understanding of everything it's responsible for, its functions, its global variables, its document strings, classes, etc. And because each module has its own namespace, that allows you to call functions what you want, and they will not clash with other identically named functions elsewhere in your code. And it means that you can think really logically about how your code is broken down, rather than just having one massive global scope with all of your variables thrown in there. It's the fundamental building block for libraries in Python. You need to understand this to use the standard library, any of your third-party libraries, and especially the large frameworks. Those, for example, who were at the Django conference yesterday, Django as a framework heavily or completely relies on modules and packages. Normally has a .py extension. Any Python program you write doesn't have to have a .py extension. By convention, it usually does. Your Python module does. And the name of the module is just the file name's base name. And we'll come to that in a minute, because we're going to talk about how you import, and that's the important part of it. How does Python find these modules? It scans through a set of directories. It's really simple. There's 4 things it looks for. It looks for the module by name in the working directory of your program. Did it find it there? No. It then looks, if you've got the Python path environment variable set, did it find it there? No. Okay. It looks in the Python standard library directories that were defined when you installed Python. There's also some path files which you can look in. I'm going to skip over that. That's a separate talk. And then when Python runs, you can look at the sys.path variable, and it's essentially a list of all of these directories strung together. I've already talked about most of this. Let's keep moving in the interest of time. Import. So import as a keyword is the most important thing you need to know about how to work with modules. It is the way to bring a module into your program and get access to all of the attributes within a module. When you use the import, what it does is it goes and finds the module, like we just talked about with directories. It byte compiles it and it executes it. So it's different to the hash include in C and C++, for example, Objective-C, languages like that, where it's a function of compilation. This is actually not just brought into your program, but it's actually executed at import time as well. And if you had a module called math.py, that was the file name, to import it, you just say import math, not import math.py. What happens if you've got a really long module name that you get sick of typing? You can use as to alias it. So if you've got something like my very long module name, and Java programmers, no more cheap shots, sorry. Some languages do love to have very, very, very long package names, and this is just a very good way of working around it, especially if you're using Python variants that work with those languages, like Jython. From's a really convenient way of sucking everything from a module in without having to reference the module name again. So you can do, for example, from module, import star, and it just sucks everything in. So, for example, instead of doing import math and then having to do math.sine, math.cosine, math.tan, you can just say from math, import star, boom, everything comes in. You can then just talk about sine, cos, tan. What you've done is you've brought all of the attributes of the module into the global scope. That's really convenient. It saves you having to type a bit, but it causes lots of problems if you're not careful. The main thing is what it's doing is it's copying names over. And I'll show you an example in a minute of how that can cause real problems, because if you do from math import star, and then somewhere else you do import math, you've actually got 2 different references to your math module working in tandem. And that may not cause you problems, except if you modify a global variable out of your module, it won't, because it's a copy, it actually won't change the behavior inside the module. So you need to be very careful with those sorts of things. Let's just quickly fire up a Python interpreter. So I'm just going to use IPython here. So if we import math, if you want to see what's in the math directory, you can do dir and it will just give you a whole list of every function, in fact every attribute of it. And if you say help and the module name, it will print out all of the information that's in the doc strings in the module. So very useful, and it's a very good reason to ensure that you always write good document strings for your module and everything inside your module so that people can easily reference them like this. There's also a really nice module called C that you can import from PyPy, and I'm really struggling with not having a screen in front of me. If you do, so you know when I did dir math, it just all went whoosh off the screen. C is just a bit more nicely formatted, And so what it does is it actually spreads it out across the screen. It's a bit more nicely formatted. And you can see quite easily what's a function versus what's a variable. So as you'd expect with a math function, your transcendental numbers like e and pi are just variables. Everything else is a function. So just to go back over this, because I really do want to make sure you get the message clear, try to avoid using from unless it's just very convenient for one specific thing. If you use from to import every module into your code base, you're going to end up with name clashes, unexpected side effects when you modify global variables out of a module. So it's much, much better to use the import keyword rather than from. Reload. Reload is useful if you are running with an interpreter and you've got your text editor open and you're making changes and you want to be able to, as the name says, reload the module on the fly to bring in the changes. Very useful in a number of circumstances where you've got software running, you have a high service level agreement, you don't want to bring your software down, all you want to do is fix a bug in a module, reload that module dynamically inside the software so it picks up the changes and it keeps running. Really useful, very, very useful, and also very, very dangerous because depending on how your module that you're reloading has made changes to variables, how it imports other modules and that, the reloading may not have all of the effects that you expect. So what I would say is make sure if you do use it and you're relying on it for mission critical code, that you understand how you're using it. It's well worth reading the documentation to make sure you're crystal clear on it. And another thing is reload works like that in 2.7. In Python 3, reload isn't a built-in, it's a function. And you have to import the imp module, and it's a function of the imp module. A few other things I just want to let you know. If you're going to write a module, don't give it the name of a module in the standard library. And that may seem really obvious, but if you don't know all of the names of modules in the standard library, it can be easy to do. And you can bang your head at the debugger going, but I can see my module, I can see that function, why isn't it importing? And that's just a catch for beginners that also catches out advanced people quite often. And the other thing is not keywords. So if, else, think of all of the Python keywords. Python will not like you importing a module with the name of a keyword. Try and avoid global variables. Importing global variables out of modules causes problems. Just avoid them if you can. Executing. If your module at the bottom has this line at the top that says if underscore underscore name equals underscore underscore main, then if you run the module from the command line, where you're actually executing it as a script, then it will go away and call the code that's in the block underneath it. This is used a lot for command line tools and also for running unit tests. So you can write your module and then have all of your unit tests executed whenever you run your module from the command line. And there's a whole bunch of really nice examples of one-liners and command tools. Sorry, I'll just, let's clear this so people at the back can see what I'm typing. So all I'm going to type here is, so that's a bit blown up, but that's this year's calendar. And all I typed was Python -m calendar. And you can do things like, what's next year's calendar, and it will print that up. There's a whole bunch of those, and we'll come back to a couple in a little while. Documenting modules. You can put doc strings, so 3 quote marks, your text, 3 quote marks, at the top of a module, and that will document the module in the same way as a function or a class. Really good for an overview, and if you want to have a look at some examples, just dive into the code in the standard library. It's one of the really nice things about Python is you get all the code to your standard library. And in particular, have a look at HeapQ. HeapQ has this beautiful lecture about how to design heap queues. That's just a little computer science lecture rolled up inside your module. Packages. So a module is where you turn a file into a Python namespace. A package is a directory that becomes a Python namespace. It's a way of grouping up modules in a directory so that they are collectively inside a namespace. So you've grabbed your functions and your classes, you've put them into a file to give you a reusable module. You've now got all these modules. You can start organising them into packages so that you have just a beautiful hierarchy to organise your code. How do you know to do that? As soon as you've got modules for a project that have, for example, different functions. You know, this is GUI code, this is code for the file system, this is code that handles the serial interface, then you can start putting those into separate packages because they've got quite different responsibilities. And basically the way it works is, as you can see here, whatever your directory name is, that's the package name. And a dot then separates it from the module or a sub-package. And the only caveat is that your package directory has to be in the Python search path, just like modules. In Python 2, there's one little bit of secret sauce you need to know about. You can't just have a directory with modules in it. You have to put a special Python file called __init__. And in Python 2, that says to Python, hello, I'm a directory, I've got modules, I'm actually a package. And it can be empty, it just has to exist. But given that it's there, you can actually put executable code in there. So if you wanted to do some code that had to be done on initialization for your modules, I don't know, connecting to a database or initializing some hardware or something, starting up your logging, you could do it there. Likewise, you can control which modules actually get exported out and how. In Python 3.3, it's optional, you don't need it. Packages, as you'd expect, you can layer them down as far as you want. Directories upon directories, packages upon packages. If you find you've got too many packages and it's just getting unwieldy to type, use the as keyword again to alias it. And why I think we've covered this. Really useful if you're working in a company and you've got lots of different Python programmers working on different things but lots of reuse, file it all into packages, especially if they're sharing that code across projects. If you want to have a bit of fun, import anti-gravity. If you're an XKCD fan, just type that into a Python prompt. If you don't think anything happened, go have a look at what happened in your web browser behind the scenes. If you want to understand the Zen of Python, import this. It will show you PEP8. If you want to know why there's no braces in Python and never will be, just type from future import braces. And I've already mentioned the HeapQ CS lecture. We've talked about the modules as command line tools. I did a presentation at the Melbourne Python user group a couple of months ago, just going through a range of different one-liners with Python. So have a look at that blog posting because the talk's there. Lots of things we didn't cover in 20-something minutes. How you can control packages and modules with the all variable. Basically, it's a way of saying, you know what, I've got I've got functions or classes inside my module or my package that I don't want the rest of the world to see by default. And you can control it with this variable. You basically say, these are the only functions I want to be exported out of my module if someone uses a from my module import star. Lots of other things. You don't have to have a directory for a package. You can have a zip file. Really good way to ship software. We've not talked about how to import packages that are zip files. From Future's really important. Lots of other things there. If you're on top of everything I've talked about today, this set of bullet points is the next set of things to learn. If you want to learn more, if you think I've whizzed through this way too fast, and I have, this is where you would go if you asked me to find out more. The online documentation has a really good coverage from beginners right through to advanced people on how to work with modules. The Hitchhiker's Guide to Python is a wonderful and opinionated and proudly opinionated guide to Python. And Zed Shaw's Learn Python the Hard Way has got some good coverage as well. I'm a big fan of learning Python, which I think is either about to or just has come out in a new edition. Anthony Briggs, who's a local Pythonista. And in terms of beautiful code, how do you know when you've got beautiful code? There is a wonderful book curated by Andy Oram and Greg Wilson from O'Reilly called Beautiful Code, talking to a bunch of leading people in the open source community about software that they think is beautiful and why. I haven't uploaded the notes yet, but they will be available on SlideShare and they'll also be available on my blog. So I've whizzed through this and there's a few small source code examples as well as notes that feed into the slides I've shown. It'll all be up on the blog if you want to download it. I'm here until Tuesday afternoon, so if you want to grab me and ask questions, please feel welcome. Thanks, everyone.